Welcome back to Smitty's Learning Room. Today we start having a look at the HSC Core 2, Factors Affecting Performance, and we're just going to have a look at the energy systems. So when we have a look at where does this content come from in the syllabus, it comes from the focus question, how does training affect performance? And then we're having a look at the learn about side here, the energy systems. Now, this video doesn't necessarily specifically look into the three energy systems, but it gives us some background information in relation to the source of fuel and the efficiency of that fuel for energy production. Now you need to remember that some of this information you should already have as background information from the preliminary course. So when we look at energy, we know that aerobic energy is created with oxygen and anaerobic energy is created without oxygen. So we also know that the body has a constant need for energy. Even at rest, the body requires energy to maintain essential body processes such as circulation, respiration and digestion. Now, obviously as our physical activity levels increase, the demand for energy also increases. So we need to have a look at how do we actually increase our energy production to enhance our performance or to be able to carry out physical activities. The basic process of energy production involves the conversion of chemical energy, which is found in our foods, to mechanical energy in the form of muscular contractions and movement. When we digest this food or the chemical energy, it allows us to produce energy through carbohydrates, fats, and protein. So all three of these things allow us to produce energy. Let's start by having a look at how carbohydrates can provide us with energy. Carbohydrates, which are found in the blood system, is what we call glucose. You may have already heard the word glucose in products that have sugar in them. So for example, like glucose lollies, and this glucose travels in the blood system. Carbohydrates, which are in the muscles and in the liver, are known as glycogen, and these are just similar to glucose but a more refined form. Glucose and glycogen are the most efficient energy source. So when we have a look at carbohydrates or glucose and glycogen for energy source or fuel, glucose and glycogen are only fuel source for anaerobic activity and high intensity aerobic activity. And at rest, glycogen contributes to 1/3 of our energy required. So if we have a look at it, we can understand why carbohydrates are so important for the production of energy, because it's used in anaerobic and aerobic activities and also to help us rest and recover. Fats are a secondary energy source and can be stored in fat cells called adipose tissue. Adipose tissue are special cells located at various sites around the body that store fat. And these can be found in males around the waist and the abdominal region, and in females around the hips, thighs and upper arms. In muscles, fat is found in triglycerides. Triglycerides are fat compounds stored in muscles that act as a source of energy. And fat cells can travel around the body in the blood as free fatty acids. And they can be stored in adipose tissue as well, and they act as a source of energy. Fats provide energy for aerobic activity. Fats cannot be used for anaerobic activity, and the reason for this is that fats require oxygen to break down for energy use. So if we have a think about what type of exercise fats are a good energy source for, obviously they would be the dominant fuel source during low intensity aerobic activities such as walking or very slow jogging, and obviously at rest where they can provide up to 2/3 of the fuel for energy. Now it's important to remember that fats cannot be used for anaerobic activity. The third source of energy that the body can use is protein. Now, the main function of protein is for the growth and repair of body tissues, and it is rarely used for fuel for energy production. So if we have a look at when it might be used, it's when the glycogen and fat stores have been completely depleted. So this could be obviously in rare cases such as starvation, or even some extreme endurance sports where athletes completely deplete all their energy and fat stores and then have to use protein as a source of energy. Protein is highly inefficient as it yields a very small amount of energy and yet uses a lot of oxygen. So if you think about the efficiency of using protein as energy, if you think about an endurance athlete and when they might actually start to tap into protein as an energy source, and the effort it would take to get the oxygen to that would actually exhaust the athlete even more. So we don't actually want to try and use protein as a source of energy. Now, obviously, because we require a lot of oxygen to break down protein for energy, it cannot be used in anaerobic energy production. So now that we've learnt that the body is fueled by carbohydrates, fats and proteins, we can start to have a look at the different types of energy systems in a little bit more depth. So we learned a little bit about these in the preliminary course in relation to the aerobic and anaerobic energy system, but now we're going to have a little look at them a little bit closer. So these three energy systems are the alactic system, the ATP-PC system, which is what you'll hear about later on, the lactic acid system, and the aerobic system, so the system that requires oxygen. So in the following videos in this series, you'll find more out about the ATP-PC system, the lactic acid system, and the aerobic system to provide the body with energy for performance.